Hey class, this is Mr. Roberts at Shasta High School, and we're going to go over the Chapter 6 practice test. This was handed out in class today at the very end of class, and your assignment was to go through the test and then check your answers with this video, and then go back through and watch the extended part where we talk about how I did these problems and how I got my answers. So first, let's start with the answer key. And to do that, I'm going to switch over to my work. So this is just a quick walk through the answers. The first equation in the first system of equations in problem 1, I got a solution of 7,1. For B, I got a solution of 7,15. For C, the solution was 2,7. That's the point of intersection. And the last one, D, this solution was -5 and 37. All right, so let's move on to page 2. In page 2, it says, find the equation of the line that goes through 8, -2, and is perpendicular to the line that goes through 2 points. So my answer was y is equal to -3/2 x plus 10. The next question, we had a sequence. The next two terms would be 27 followed by 7. It only asks for 2. The generator for this sequence is multiplied by 1/3. It is a geometric sequence. I know that it's geometric because all the terms have a common ratio. Or I said another way, it uses multiplication to generate the new terms. The explicit form of that sequence is T of n equals 1,701 times 1/3 raised to the nth power. For 4a, the simplified version is 4x to the 10th, y to the 4th. 4x to the 10th, y to the 4th. For b, the answer is 5y to the 5th over x squared. I did change this problem a bit. The answer was still the same, though. The dogs will both weigh 12 pounds after 5 years. 12 pounds after 5 years. Last question, number 6a, y was 4. For 6b, y was -11/12. And then the last question there, y is the number 20. Y equals 20. All right, so those are the answers. Now I'm going to go back through and do each one of these problems. If there's any questions you missed, go ahead and circle those and maybe just fast forward to the ones that you need to look at. All right, so for question 1, I did use the elimination method. It turns out this was a perfect candidate for elimination because as I looked at the equations, I can see that it had a +3y and a -3y. So it's always true that if you have equal things and you add equal things, you will get things that are equal to each other. What's nice about this is when I add my equal things to the equal things, it turns out the y's eliminate, right? Because I've got a +3y plus a -3y, that's just 0. So what I get on the left-hand side is I've got a single x plus 4 more x's, so this becomes 5x, and that equals 35. Therefore, x would equal 35 over 5, right? 35/5, or x is 7. And now that I know x is 7, the next thing I need to do is figure out exactly what y is. So to calculate y, I'm going to basically pick either one of these two equations. It doesn't matter which one at all. I think in my answer key, I picked the top equation, so just on principle, I'll pick the bottom equation to figure out what y is. So if I use this equation, I now know what x is, so I'm going to write everything except I'm going to replace x with what I know x to be. So this equation becomes 4 times x, which is 4 times 7, and then minus 3 times y is 25. 4 times 7 is 28. 28 minus 3y is still 25. Now if I take and I subtract 28 from both sides, I'm going to get -3y is equal to 25 minus 28. My calculator says is -3, and I know that it's -3. Therefore, y is -3 divided by -3, and that is +1. So the answer is x is 7. So we always write these as an ordered pair. X is 7, y is 1. All right, let's go to part B. This is our system of equations, and I can see in both I have y solved but they're both y equals. They're in slope-intercept form, right? Y equals form. So I'm going to go ahead and use the equal values method. Certainly in the context of this system, it is true that y is equal to itself. So I can take the top y, which is 5x minus 20, and set it to the second y there, which is 2x plus 1. Y is y. What do I get? Let's take away 2x from both sides. When I do that, I'm going to get 3x minus 20 is 1. Subtract, or add rather, 20 to both sides. Adding 20 to that side. Add 20 to the other side. And now I'm dividing both sides by 3, and I get 21 over 3, which is 7. So x is the number 7. And now we need to figure out what y is. These are both in y equals form, so this is pretty straightforward. To figure out what y is, it just says take x and double it. So take 2 x's and then add 1. 2 times x is 14, and 14 plus 1 gives me 15. So y is 15, and x was 7. So again, as an ordered pair, our solution is 7, comma 15. 7, 15. All right, part B. For this, I believe I use substitution in my answer key, and I'm going to pick that again. The reason why I'm picking substitution is it turns out the top equation, right, tells me that y is 2x plus 3. That's what y is. It's 2x's, 2 times x plus a 3. So I'm going to replace y in the bottom equation with that value. So what I'm doing right now is just rewriting the second equation again, but I'm replacing y, or substituting in y. So I write 3x and then plus 2 times y, but instead of y, I'm writing 2x plus 3, and then that will equal 20. So if I use the distributive property, I've got 4x plus 6 is 20. 7x plus 6 is 20. That means that 7x is the number 14, and x is the number 2. So we have found x. What we need to do to finish this is we need to figure out what y is. I think I'm just going to go ahead and pick this because it tells me what y is, right? So this is me just using the second equation to calculate y, or the top equation rather. Y is 2 times whatever x was, and you can see I found that x was the number 2. So y equals 2 times 2 plus 3, y equals 4 plus 3, y equals 7. So our solution is x is 2, y is 7. And then the final system of equations problem on page 1, part D, has this system. And this system, I mean, there's really no wrong method. I just want us to select a method and use that method. I'm going to use elimination, but in order to use it, I'm going to use elimination with a slight modification. And my modification is this. I'm going to go ahead and through it multiply this second equation every single term on both the left and right hand side. Each term is going to be multiplied by a -1. So I always like to rewrite the other equation too. So I'm going to write that. This is still 5x plus y is 12. Nothing's changed for that. However, the bottom equation is going to become, via multiplication by -1, it's going to become negative 7x negative y equals -2. All right, now that we're set up and we're in perfect form to do elimination, I'm going to take the equal things, and I'm going to add the equal things, and I'm going to get equal things. 12 plus -2 is going to be 10. That's my right-hand side. Over on the left-hand side, you can see that there is a positive y and a negative y. When I combine those two, they equal nothing, or 0. And then I've got a 5x and a -7x, which is -2x. So if I divide both sides by 2, I get that x is 10 over -2. X is the number -5. So we know what x is, and we know not what y is, but we're going to figure out that pretty quickly. It does not matter which equation I pick. I believe that I'm going to go ahead and pick the top equation. So I'm going to go ahead and rewrite that top equation. Right, this is what I mean by the top equation. And I'm going to go ahead and write 5. A place for x plus y is 12. So I've just faithfully copied that equation. But instead of writing x, I'm going to plug in what we know x to be, namely x is negative 5. So this becomes negative 25 plus y is 12. And then if I just add 25 to each side, adding 25 to the left-hand side gives me y. And when I add 25 over to the right-hand side, I get 37. So my solution is x was negative 5 and y was 37. All right, let's go on to page 2. In page 2, it says, and I quote, the equation of the perpendicular, find the equation of the perpendicular line that goes through a point. Okay, so we know that we have to hit this point, right? And this point that we have to go through, our answer has to go through it. That means once we get our answer that when I plug in x is 8, my equation should give me that y is negative 2. So I have to hit that point, 8 comma negative 2. It also says that it's going to be perpendicular. So I know that lines that are perpendicular, they have this relationship with their slopes. We've seen this when we rotate the Cartesian coordinate plane. Basically, the slope triangle, the rise and run switch places, and what was positive becomes negative and vice versa. So slopes, we shorthand that by just saying the slopes are going to be opposite in sine and reciprocals. So if I look at this, if I want to find the slope of the line that I have here, I do understand that the slope is this, this value, right? I could say that's a y minus this other y. And then I'm going to divide that by an x divided by the other x. So slope is this ratio of y values minus the x values. Of course, the y values are those things that are going to go on the top, right? The delta y. Oh, I can make a triangle. That's so much fun. It's the delta y's. And in the denominator, we're going to put the delta. I wanted to make that a triangle. The delta x. There we go. So the change in my y values looks like 6 minus 4. And the change in my x values look like 9 minus 6. Okay, what am I doing? I'm taking this y and I'm subtracting this y, right? 6 minus 4 is in my numerator, and I'm going to take the 9 minus 6, and that goes in my denominator. So what's my numerator? 6 minus 4 is 2, and 9 minus 6 is 3. So the slope that goes through this line is 2/3, right? The slope that goes through the line, that goes through those 2 points, the line through the 2 points is 2/3. But I'm not wanting that slope because I want a line that's perpendicular to that. So the slope that I'm going to use is going to be negative 3/2. Look at what I did, right? I had a positive 2/3, it became negative, and I took the reciprocal. Now all I have to do is ensure that it hits the point 8, negative 2. So I could start with this idea, right? Slope-intercept form, y equals mx plus b. And if I take away mx from both sides, right, I remind myself that that is exactly b. And that's what I want right now, right? I'm trying to find my y-intercept. I already know what my slope is, right? My slope is negative 3/2. I need to figure out what my y-intercept is. So how do I do that? Well, I'm going to plug in the y value that I know, which is negative 2, right? The y value that I know is negative 2 minus, negative 2 minus, and then I'll open parentheses. My slope was negative 3/2, close parentheses, and I'm going to multiply that times 8. Well, 8 divided by 2 is 4 times 3 is 12. It looks like negative 2 minus 12 is what I'm looking at here, I think. I think this is negative 2 minus, no, negative 2 plus 12, because it's this minus negative 12. So negative 2 plus 12. So my y-intercept that I'm going to use is 10. Now I'm going to write my answer down, and I'm going to check it a bit. Y is equal to negative 3/2 times x, and then plus 10. So how do I know this works? Well, again, I said that if I plug the number 8 in, right, this equation should give me back negative 2. And you can check this on your calculator. I could go like negative 3 times 8 is negative 24. Negative 24 divided by 2 is negative 12, and negative 12 plus 10 is negative 2. So it has the correct slope. It has the opposite reciprocal slope. of the line that goes through the two given points, and it produces the correct output when I feed it 8. All right, on to question 3. It says, consider the sequence. And if I look at these terms, I could play with them on my calculator if I think there's a common difference. But it turns out for this sequence, there is a common ratio. And by that I mean if I take 189 and I divide by 567, I get the same value as 63 divided by 189. In each case, right, these are equal to 1/3. They're equal to 1/3. So I know that this is a geometric sequence because of that. It has a common ratio. And the next two terms would be 27. That's 63 divided by 3, or times 1/3. And then 27. Oh, I think I had the wrong answer on my answer key. I'm pretty sure, because I think on my answer key I had 27 divided by 3 and I wrote 7. I think 27 divided by 3 is 9. That's embarrassing. I literally had the wrong answer on my answer key. And honestly, I did not see that when I wrote it down on my answer key. I had that there, but it's funny going over the test and looking at them like, wait a minute, 27 times 1/3 is not 7, it's 9. So I apologize for the answer key. If you're watching this video because, hey, how do you get 7? I got 7 because I was wrong. Let's see, the generator for this sequence, it's an operation and a value, so the operation is multiplication, and the value is by 1/3. So multiply by 1/3. It is a geometric sequence. It also says, how can you tell, right? How do I know that it's geometric? It's geometric, and I wrote this on my answer key. You can go back and look at it. I said, this sequence has, it has a common ratio, right? Meaning new terms are generated by multiplying by this common value, or it uses a multiplier or multiplication to generate new terms. And then finally, we're asked for what's the explicit formula for this sequence. Well, the explicit formula does need to know what the 0th term is. I know that the first term is 567. So if I want to go back and figure out what the first term is, right, I can either divide by 1/3, right? I can divide by 1/3, or I can take 567 and I can multiply it by 3. It turns out both give me the same value. The 0th term is 1701, so I'd write the explicit formula would be T of n is equal to 1701 times 1/3 raised to the nth power, and that's it. So you can see I have both the common ratio, right? This number is the common ratio, and this 1701 is the 0th term. Next, simplify. Your final answer should have only positive exponents. So this is a little difficult because I know that when we see things like this dot, we think like it's something times something else, and these parentheses confuse us too. But I just want you to look at it and just say, hey, there's just a whole bunch of multiplications going on. This is being multiplied by this, it's being multiplied by 4, it's being multiplied by x to the 7th, and it's being multiplied by y to the negative 3rd raised to the positive 2nd power. So because it's multiplication, right, the commutative property of multiplication assures me that I can rearrange the order that the multiplication happens and I don't get a different answer. Simple example, right, if I have 2 times 3, that's 6. That's the same as 3 times 2. They're both 6. So I know I can do something like rewrite this so I've got my x3rd times my x to the 7th power. And when I look at those two, that is x to the 10th. So I've taken care of all of my factors of x by collecting them as x to the 10th. The other thing that I can see is I'm just going to grab this 4 and put it right in front. So it's a 4 times x to the 10th. And there is a y to the 10th. And then I want to bring this in too, and there's also a y to the negative 6th power, right? So if I have a power that's raised to another power, it's it's two of these, right? It's y to the negative 3rd times a y to the negative 3rd, which is y to the negative 6th. Now, final thing I can do is I can combine those, right? Y to the 10th times y to the negative 6th is going to be y to the 4th. So the final answer that I should write down on the line over there is 4 times x to the 10th times y to the positive 4th power. So there's our answer for A. Let's move on to B. For B, I think I'm going to go kind of old school here. I'm going to go way back to the beginning of last term. And I'm just going to go ahead and write this in expanded form. So it's a 5. It's a factor of 5. And then it times 2 factors of x, and then it's times 5 factors of y, and in my denominator, I have exactly 4 factors of x, x, and x. When I look at this, I can see, right, there are some factors that line up perfectly, and these are common factors. So when I have the xx over xx, that's equal to 1. So this is a problem where I have a giant 1. And when I look at what's left in the numerator, right, in the numerator, I'm left with a factor of 5, and I'm left with 5, 1, 2, 3, 4, 5 factors of y. So 5 times y to the 5th. And in the denominator, it turns out we are left with only 2 factors of x times x squared. On to our last page. I think I rewrote it here. Yes. Nope. I think your copy that you got, the wording of this changed, because I think I gave you the let statement. But let's go ahead and look at it. So Jay has a poodle that weighs 7 pounds and gains 1 pound per year. So look, if I was just to say poodle, Poodle, if y is the weight of the dog and x is how many years go by, if y is the weight and x is how many years go by, the weight of this dog is x plus 7, because right now at year 0 it weighs 7 pounds, and every year that goes by it gains 1 pound. So that means that I have a slope or rate of change of 1 pound per year. So the poodle, that's what we're looking at. And then the Sheltie, Ltie, the Sheltie weighs 2 pounds right now, right? And it is gaining 1 pound every 6 months. 1 pound every 6 months. Well, if it's gaining 1 pound in 6 months, right, we know that 6 months is half a year, right? In pounds per year, that's 2 pounds per year. So every single time x goes up by 1, it gains 2 pounds. So the Sheltie's equation is y is equal to 2x plus 2. It's been a while since we've looked at dimensional analysis, but I just want to just confirm this. So 1 pound, 1 lb per 6 months. If I want to turn this into pounds per year, I know that I want the months to go away. So I know that there are 12 months in 1 year. And if I look at this, right, you can see that my units, months, M-O-N-T, there's a missing H in there, months over months, those units are gone, and I'm left with 1 times 12 over 6. 1 times 12 over 6 is 2, and the only units that are left is in my numerator. I've got pounds, so 2 pounds per year. So dimensional analysis confirmed what we knew intuitively, that 1 pound every 6 months is the same as 2 pounds per year. It's nice to practice that dimensional analysis with something that you can obviously check because it's so intuitive. So how we're going to solve this? Probably using the equal values method, right? It's clear that y is y, so I know that the top y for the poodle is x plus 7, and the bottom y for the Sheltie is 2x plus 2. Therefore, if I subtract x from both sides, I get 7 is x plus 2, and when I subtract 2 from both sides, I get that x is 5. So 5 is how many years it will take until their weight is the same, right? I want to know when the y the y of the poodle is the same as the y as the Sheltie. That's how this equation works. So that's why I said y to y. That happens in 5 years. And what's the weight of the dogs? Well, these will both say the same thing, right? 2 times 5 plus 2, it looks like 12 pounds. And if I look at the Sheltie, what is that? That's 5 plus 7, which is also 12 pounds. So the dogs will both weigh 12 pounds after 5 years. And then the last question, question 6, there are 3 equations that we need to solve. On this first one, I'm going to rewrite this. I have a binomial times a binomial here, right? I know that these are binomials because I have addition in between these, their terms, right? So I've got a y plus 4 times a y plus 1. One option is to consider a generic area model. So along the top, I can say, hey, there's a distance of y plus a distance of 4 more. And then down the side, I can say there's a distance of y plus a distance of 1 more, right? So each one of these has an area, and I can find the area just by multiplication. So in the top left corner, y times y is y squared. The next corner over, 4 times y is 4y. Below that, 1 times y is just a y, and then 1 times 4 is 4. You can see that there is this shared common factor, or these two are like terms, rather. I've got a y plus a 4y, which gives me 5y. So this is the same as y squared plus 5y plus 4. That's what the left-hand side is. And we've seen that, you know, there are shortcuts to this. Certainly I can multiply this first term times this first term and get the y squared. And then I can multiply the y times 4 and get 4y. And then I can multiply the 4 times the 1 and get that 4 at the end. And then don't forget that there's this 1 times this y, which gives me my last y. So that's one option that we have too, especially if it's a binomial times a binomial. That's a pretty quick way to figure that out. On the other side, we've got just y squared plus 24. Both sides have y squared. And if I subtract y squared from both sides, it's gone. So this equation becomes 5y plus 4 equals 24. Therefore, 5y is 20. And it looks like y has to be the number 4. If I come back up here and I check this, 4 plus 4 is 8. So this becomes an 8 times 4 times 5. This becomes 40 on this side. So this side equals 40. Over on the other side, I've got 4 squared, which is 16 plus 24. And if I take 16 and I add 24, 4 and 6 is 10 carried. I get 40 also. So this is important, right? I know that this works because both the left-hand and right-hand side are equal to 40 when y is the number 4. Boy, that's messy looking. Feel free to check those on your calculator. I like to see it when you write this, 40 equals 40. Check. I just can understand that, yeah, you did check it. Both sides become 40 when you figure out that y is 4. Next equation. This only has numbers in the denominator. There's not a variable down in the denominator. So to clear all these fractions, all I need to do is multiply by a factor of 2 and a factor of 3. And it turns out a factor of 2 and a factor of 3 is the number 6. So what I'm going to do is I'm going to multiply every single term by the number 6. That means this term is going to be multiplied by 6. This is going to be multiplied by 6. This is going to be multiplied by 6. And this is going to be multiplied by 6. So when I do that, what do I get? Well, I'll just write it first. So I've got 6 times the 2y plus 1 over 2 plus 6 times 2 over 3 equals 6 times 3 plus 6 times 3y. So if I look closely, I can confirm that this one got a 6, this one got the 6, this one got the 6, this one got a 6. Every single one of my 1, 2, 3, 4 terms, 2 terms on the left-hand side, 2 terms on the right-hand side, all got factors of 6. Now I can just simplify, right? 6 divided by 2 is 3. 6 divided by 2 is 3. So I'm going to go ahead and distribute this 3. This is going to become 3 times 2x, which is 6y plus 3. That feels like a possible place where I could have made an error. So I'm actually slowing down. I'm looking at it. 6 divided by 2 is 3. So I multiplied both the 2y times 3 and the 1 times 3. Plus 6 divided by 3 is 2. 2 times 2 is 4. Equals 6 times 3 is 18. Plus 6 times 3 is 18y. Okay, so if I take away 6y from both sides, and I'm going to add the 7, I get 7 is 18 plus 12y. And then if I take and subtract 18 from both sides, 7 minus 18 is going to give me negative 11. So I've got negative 11 is 12y. That means I think that y is going to be negative 11 over 12. This step right here, oops, equals y. This step, right, often I see us get this backwards, but you can see that y is what I want alone, and if I focus on that part with the y, and I divide that side by 12, right, and then I divide the other side by 12, so y is negative 11/12. I highly recommend that you take a value like that, use one of our classroom calculators, store it, and then confirm that both the left and the right hand side are the same when y is negative 11/12. Our last equation is, I apologize, it's too simple, right? 3y is 60, therefore y is 20. Even I can check this. If I plug the number 20 in, 3 times 20 is 60, 60 plus 10 is 70. When y is 20, both sides of that equation become 70. So that's the last question. If you come to class early tomorrow, right at the end of lunch there, you can ask me questions if there's any clarifications. I did make the one error on the answer key. It was on question, what was that? Number 3A. But if there's anything else that's confusing, or maybe you notice, Mr. Roberts, you need to take a nap before you do this because you made another mistake. Please let me know. I hope this was helpful. Look forward to seeing you in class tomorrow. We'll be taking the individual Chapter 6 test. And until then, have a good evening.